In this ProteusDS training session, we're going to go through some fundamentals of working with PostPDS and post-processing simulations. In the agenda, we're going to go through PostPDS and look at some simulation results as an example. We'll review camera controls, a few view controls, interaction with bathymetry, and some basic plotting. Optionally, there's a set of simulation results in a folder PostPDS you can download. You double click on the results.pdso file, it'll open up in PostPDS. But we're not going to open those up just yet. When you first open up PostPDS, you'll see a window that indicates specified load options. Most of the time, we use just the default settings and click on OK and move on. But if you have a large data set, it's kind of handy to be able to specify a load, a time range to load, something that you might be interested in taking a closer look at. For complex C states with a lot of wave segments, it may slow down the rendering of the visualization, so you can limit the number of wave segments and detail on the sea surface just when it's starting up and loading. But you can change this after you've loaded it as well. The camera controls are the same as in the visualizer camera in ProteusDS Simulation Toolbox. The camera controls are revolve around the focal point of the camera. The middle mouse button will cause the rotation around the focal point, and the right mouse button changes the location of the focal point itself. It pans it around. We can open those results now and use this as an example. We're going to use default settings. So you can rotate around using the middle mouse button and then pan around using the right mouse button. The mouse wheel allows you to zoom in, but it's not moving the position of the focal point. And when you zoom in, note the sensitivity has changed a lot. The camera won't move nearly as much as when it's zoomed out. You can move the focal point using WS forward and backwards, and side to side using A and D. There's two camera modes in PostPDS: perspective projection, which is typically what you would see and what you would expect to see in reality. The problem is that when you're looking at really large scale systems, you lose sight of them and you can't get a sense of what it looks like. The alternative projection is orthographic. It's an artificial projection, but it's useful for comparison of systems, looking at large scale systems, and comparing side views of systems and things like that. You change that by clicking on settings and then switching between perspective and orthographic. So for example, I'm going to turn off the water, and now we can see this bathymetry, which is a few kilometers in scale. It's kind of hard to see the whole thing at once, and if you try to look down and zoom out, you get a bit of a skewed view because of the perspective. So we can change to orthographic. And now if we go back to home and select camera preset top, now you've got a nice orthographic projection of the top view of all the bathymetry. But we're going to go back to perspective for now. Just like in the pre-visualizer, you have the global frame orientation with X, Y, and Z pointing to north, east, and Z positive down. There's also a compass, which helps keep track of the orientation. It's the same orientation as the global frame, regardless of wherever the global frame is located. The structure of PostPDS has several windows. So this is what you'll see. This is what we're seeing as we're playing with PostPDS right now. The 3D window is this region here. This is the ribbon where there's a number of settings. We've already started exploring that region. There's the camera controls under Home. You can change the specific pitch, zoom level, and X, Y, Z location of the camera focal point. There's playback controls, which allow us to play back the simulation results, and the time slider here also reflects the simulation time. The render mode, which is rendered mode or engineering mode. Engineering mode lets us see the water surface as a grid instead of a detailed view. This is handy again when there's a very complex sea state and a lot of wave components. It also shows things like cables and nets with minimum 1 pixel thickness, so you can see things that are otherwise far away. The tree here allows us to select different D objects and focus the camera on them. If you double click on one of them, the camera focal point will jump to that one. You can change the colors as well, set color, and see different kinds of plots here. X versus time and so on, and orientations and accelerations, but these are also available in the text file output results. If you do have a custom bathymetry in the simulation, there is a number of plots you can use by seabed and bathymetry plotting, like for example plot depth. There's some default range values here for the color, and it just helps give a visual sense of what's actually going on with the bathymetry itself. These other plots for slope give an indication of how steep certain sections are. Of course, that's going to be a function of the discretization of the mesh of the bathymetry as well. And exclusion zones is more about showing areas that exceed a certain steepness of slope. This might be handy for planning marine operations or anchor locations. If an anchor is going to be installed where it's too steep, it may mean that the anchor is going to slide down, or there might be some trouble during installation. So in review, we took a look through a bunch of features of PostPDS and looked at some simulation results. Take your time to play with the results here. You can play back some results and see some of these entities sinking and falling. Reset the simulation, try it again. Practice the camera controls. We looked at different view controls, bathymetry interaction, and the availability of different options of plotting through the tree. Thanks for watching.